Well, the effects of climate change are drastically affecting oceans around the world. According to a new study, the ocean circulation in the North Atlantic is likely to collapse by 2025, and this as a result of climate change. Scientists say that the collapse of this system could lead to disastrous weather conditions across the globe. But what is this system and how will it have a disastrous effect? Let me explain. This ocean current system is called the Atlantic Meridional Overturning Circulation. It is a vital system of the ocean currents that circulates water throughout the Atlantic Ocean. This circulation takes an estimated 1,000 years to complete, but has slowed even more since the mid-1900s. Now, where is this located? The Gulf Stream is a warm and swift Atlantic Ocean current that originates in the Gulf of Mexico. It flows through the Straits of Florida up in the eastern coastline of the United States, then diverges east near North Carolina and moves towards northwest Europe as the North Atlantic Current. Now, how does this system work? This circulation movement is driven by differences in water density. So the AMOC is like a conveyor belt which transports or rather carries warm water from the tropics towards the North Atlantic. This is where the water gets cooled and it sinks. It then returns to the tropics and then to the South Atlantic as a bottom current. From there, it is distributed to all ocean basins via the Antarctic Circumpolar Current, which is the most important current in the Southern Ocean and the only current that flows completely around the world. So how is the system collapsing is the next question. Well, as the ocean heats up, the ice melts, more fresh water flows into the ocean and in turn reduces the water's density, making it less able to sink. When waters become too fresh, too warm or both, the conveyor belt stops. What would be the implications of the collapse of the AMOC current? Now let's take a look at that. Well, since the current plays a crucial role in the climate system in helping regulate global weather patterns, its collapse would have enormous implications. This includes much more extreme winters in the Northern Hemisphere and decreased rainfall over Europe. Sea level rises can affect parts of Europe and the United States, and this could influence the shifting of the monsoon in the tropics. For more on this, we have with us Professor Peter Ditlevsen, who is a professor of climate physics at the University of Copenhagen. He is also the co-author of the study which predicts AMOC collapse and says that we are nearing the tipping point. Professor Peter, my first question to you is, this certainly sounds ominous. Now, considering the weather conditions that we see around the world, how likely is it for this situation in the report to be a reality, and how serious do you think the matter really is here?
Well, there are two things to that. One is, of course, that it is very serious if it happens. I would say I would just make sort of a small correction. So what we do predict is that it's likely to happen in about mid-century, which is 35 years from now. But the risk that it is already to happen as soon as next year, or actually about to happen now, is existing. But we have to realize that this is a slow process in terms of our lives. So a new study that just came out of Utrecht University in the Netherlands does do a computer model simulation. So this is a climate model of the IPCC climate model types that actually shows in detail, according to this model, what will happen in different parts of the world. And this is definitely something that will especially influence Europe severely if it happens.
Okay, you do mention the paucity of time. So I am going to ask you something on the line of the time constraints here. Is there really not much that can be done to reverse this change? Is it already too late? If it is too late, can we at least reverse or at least reduce the effects of this?
I'm an optimist in the sense that if we realize that this is really a risk that we have to, as world society, to react on, it is not too late, but it is a very difficult job to do. Even if we have passed that tipping point, or is about to pass that tipping point, the possibility of reversing is there. However, if this depends on the amount of greenhouse gases we've emitted to the atmosphere, that is very difficult to reverse. So what we have to hope for is that we can postpone it out in time until we have succeeded with a full global green transition.
Okay, thank you so much, Professor, for joining us with your insights. While science warns, it also gives a ray of hope for the imminent future. Thank you so much for joining us on this broadcast. On similar lines with what Professor Peter was telling us about, the back-to-back storms that lashed the United States northeast region in January were not an aberration. Scientists believe that the storms were more of a sign of things to come than an anomaly. Now, January's onslaught caused by the winter storm Finn was devastating for working waterfront communities in Maine. Dozens of docks, buildings and wharfs were damaged or destroyed. According to the State Departments of Marine Resources, the combination of storms in the second week of January, coupled with high tides, brought major damage in a state where activities like commercial fishing are vital.
On January 10th and 13th, two record-breaking coastal storms hit Maine back-to-back, and they led to some of the highest water levels we've ever measured along the coast since we started measuring in the early 1900s.
Another storm brought flooding to Massachusetts and New Hampshire on Tuesday as a powerful winter storm battered the region, blanketing New York for the first time in 2 years and causing flight cancellations and school closures. While preparing for a future of stronger storms, worse flooding and increased erosion will make for difficult choices in many coastal areas. Inland communities are not immune to flooding from weather events like the January storms. The storms are becoming more of a norm than the exception. Well, China has some of the most polluted cities in the world. However, the launch of air pollution mitigation policies helped in a big way. And that is a sizable decline in suicide rates. A new study, including data from some 1,400 air quality monitoring stations across China, found that suicide rates rise as air quality declines. In 2013, China launched its ambitious Air Pollution Prevention and Control Action Plan. This plan tackled industrial emissions and vehicle pollution and focused on the country's transition to cleaner energy sources. The plan's success quickly became evident in both improved air quality and declining suicide rates. Between 2010 and 2021, the annual suicide rate dropped by 50%. Researchers then took advantage of these striking trends to see if they could isolate the effects of air pollution on suicide risk from other factors linked to suicide. They dug into weekly air quality data and studied the meteorological phenomenon called thermal inversions. Thermal inversions trap air pollution close to the ground in a layer of cold air pinned down by a hotter band above. These inversions typically last only a few hours, but at a county level, they can raise the weekly average concentration of fine particulate matter in the air by about 1%. Now, these small particles can travel directly to the brain, altering its chemistry in as little as 24 hours. It then leads to poorer mental health and possibly worse emotional regulation in the long run. Now, the researchers have found that in the county where this phenomenon existed, there was an uptick in suicides. This study is confined to China and only shows a correlation between smog and suicide rate. It is yet to be seen if the findings hold true for other countries as well. The new findings have revealed that the extent of global coral reefs is nearly 25% larger than what was previously estimated. This discovery is equivalent to an additional 64,000 square kilometers, roughly the size of Ireland. Through a combination of satellite imagery, machine learning, and ground-based data contributed by a global network of coral reef stakeholders, researchers have expanded the known shallow reef area to 348,000 square kilometers, This is about the size of Germany. Within this expanded area, approximately 80,000 square kilometers feature hard bottoms. Now, these coral-rich habitats are often frequented by snorkelers and scuba divers. Previously, gathering comprehensive reef data involved collecting information from various sources, which led to uncertainty in pinpointing reef locations. However, recent advancements in high-resolution satellite technology allow researchers to accurately map reefs to 30 meters down. This process was aided by direct observations by over 400 individuals and organizations worldwide. By utilizing machine learning algorithms that trained on vast amounts of satellite data, the team behind the Allen Coral Atlas produced the world's first comprehensive map. Now, this map detailed coral reef extent and composition. These maps are already being utilized by reef management agencies worldwide for conservation planning and threat assessment. Coral requires a solid foundation, typically attaching to rock, as it cannot thrive on sand alone. Polyps must adhere to these hard surfaces before they can expand the reef using their limestone secreting bodies. Now, despite these groundbreaking discoveries, coral reefs face existential threats from climate change-induced ocean warming and acidification. However, the newfound awareness facilitated by these discoveries have encouraged conservation efforts in various countries, including Indonesia, Panama, and Australia. Major players in the financial world are rethinking their involvement in the fight against climate change. Three giants, JP Morgan Chase, State Street and BlackRock, have distanced themselves from the Climate Action 100+, an investor coalition pushing companies to curb emissions. These firms collectively manage nearly $14 trillion in assets. While the firms cite concerns about maintaining independence, the decision comes amid growing pressure from Republican politicians who view such coalitions as anti-competitive. In total, 13 companies have left CA 100+ in recent years. JP Morgan and State Street claim their departures stem from wanting to maintain independent control over their investment decisions and engagement strategies. Investors like Vanguard, which never joined CA 100+, and insurers who left similar groups also raise concerns about independence. BlackRock, while remaining a member, has shifted its involvement to international arm, suggesting a less active approach in coalition's North American efforts. This shift removes $6.6 trillion, or two-thirds of BlackRock's total assets, from the coalition's direct influence. Now, despite losing these key players, CA 100+ has seen overall growth in its membership, with more than 700 firms, including 60 new additions. This development, however, leaves the future of climate action on the Wall Street uncertain. Will others follow suit, or will the industry find new ways to collaborate and drive change? That is something that only time will tell.